Today is going to be 31-7. We're going to take a look at coordinate trigonometry. So today you guys are going to be able to find all 6 trig ratios from a coordinate and then find 6 trig, or at least find the trig ratios from a ratio and various constrictions. So when angles are greater than 90 degrees, we utilize reference angles to determine the trig ratios. When an angle is in standard position, we say that the reference angle, it's going to be a definition, is the acute angle formed by the terminal side and the horizontal axis. So let's take a look at this. This right here is my angle. This is my terminal side. And so if we're saying that the reference angle, or a reference triangle, is going to be the acute angle formed by the terminal side and the horizontal axis, this is the terminal side, this is the horizontal axis. And so it's going to be referring to this triangle being able to draw from that. Notice it's perpendicular to the x-axis, and my hypotenuse is the radius. Now, to be able to find what that reference angle is, we're going to have to use a little bit of geometry to help us here. If I know this rotation is 262, and I know that this portion is going to be 180 degrees, the remaining portion is going to be my reference angle. So that means if I do 262 minus 180, I'm going to get 82 degrees. Now let's take a look at an example when we have radians. So let's just say if I rotate 4 pi fifths, that means that this remaining piece right here, this is going to be my reference angle, so I can create my triangle like that. And so to be able to find that, if this is 4 pi fifths, the entire rotation is pi, or 5 pi fifths. And so to find that little piece there, I need to subtract them. 5 pi fifths minus 4 pi fifths give me pi fifths, which is going to be my answer. And so now defining this, because we're drawing these triangles in our coordinate plane, I can make the association with those values with my trig ratios. So if I have my triangle here, I can say that this distance is x and this distance here is y. So that means that my sine ratio from this is going to be opposite over hypotenuse. My cosine value is going to be adjacent over hypotenuse. My tangent value is going to be opposite over adjacent. My cosecant, okay, it's a reciprocal, so I need to flip that. My cosine, I need to flip that. My cotangent, I need to flip that. Okay, they're just reciprocals of each other. And now to find my radius, we're just going to use the Pythagorean theorem. So it says, first example, let's find the 6 trig functions of theta if the given point is on the terminal side of theta. So plotting this, 1, 2, 3, 4, 1, 2, 3. So here's my point. Now drawing this out, this right here is going to be my reference triangle, and here is going to be theta, or my reference angle. In this case, theta and my reference angle are the same thing. Now labeling this x distance is 4, this y distance is 3, and so using the Pythagorean theorem, I could say that this is going to be 5. Plus it's a Pythagorean triple, so I can do it that way. And so now that I have my triangle labeled, I can go through and I can state my ratios. My sine of theta is going to be y over r, or opposite over hypotenuse. My cosine of theta is going to be adjacent over hypotenuse. My tangent of theta is going to be y over x. My cosecant, remember they're just reciprocals, so you flip it. Secant, they're just reciprocals, so you flip it. Cotangent, they're just reciprocals, so you flip it. And so those are going to be my 6 functions. For this next one here, if I were to plot this value, -5 and -5, I'm going to get this value here. And so here's going to be my triangle. My reference angle is this, even though my rotation is going to be this. So now labeling this is going to be -5 and this is going to be -5. Now if I use the Pythagorean theorem, this is going to be 5 root 2. And so now going through and stating my triangles, my sine value is y over r, which is -1 over root 2, which is negative root 2 over 2. My cosine value is going to be x over r, which is the same value. And then my tangent is going to be y over x, which is -5 over -5, which is 1. Now, you guys can find the reciprocals, right, just by flipping them. So kind of talking about this, the first thing that I did in both of these examples is I drew the point on the graph. So I plotted the point on the graph. Then I sketched in x and y. So I sketched in my x, sketched in my y, and so that was able to create the triangle that I have here. To find r, I used the Pythagorean theorem, which is what I did there. And then I used SOHCAHTOA to find all the ratios. In this case, I only found 3, but you guys can find the reciprocals just by doing the reciprocal. Now, one thing to kind of get across here is the fact that because we said that the sine of theta is y over r and cosine of theta is x over r, what's being implied there is that x relates to cosine, y relates to sine. So that means when x is positive, cosine is positive. When x is negative, cosine is negative. When y is positive, sine of theta is positive. When y is negative, my sine of theta is negative. And so because of this, I basically get a table here of all the different values of that. This first one, when cosine theta is greater than 0, well, let's think of it this way. My x and y's are positive here, which is why my cosine and my sine are positive here. To find tangent, it's y over x. Well, positive over a positive gives me a positive. Whereas like this one here, my x and y are negative in this quadrant, so that's why my cosine and my sine are negative. That's why it says a less than 0, which means it's negative. My tangent, which is y over x, negative divided by negative is a positive, which is why my tangent is positive. So let's practice finding a few of these. Let's find what quadrant it's going to be in. So if my sine of theta is less than 0, that means my y is negative. My cosine theta is less than 0, that means my x is negative. Well, the quadrant that has both of them negative is going to be quadrant 3. My sine of theta, we relate that to y. Well, it says greater than 0, so it's positive. My tangent theta is y over x, and it's less than 0, so that means one of them is negative. Well, because my y is positive, this has to be negative, and so that quadrant's going to be quadrant 2. My sine of theta here is less than 0, so that's y, and secant relates to cosine. Cosine relates to x, so that's going to be x. Well, sine is less than 0, so that's negative. And secant is greater than 0, so this is going to be positive. So the quadrant that has a positive or negative y and a positive x is going to be quadrant 4. And then the last one, it says cotangent of theta is less than 0. Well, my cotangent is going to be x over y. Cosecant, it says it's less than 0 here, so I don't know which one's negative. One of them has to be negative, though. Cosecant is greater than 0. Cosecant relates to sine. Sine relates to y. My y is greater than 0, so that's going to be positive, which forces this y to be positive, which makes that one a negative. And so negative x and a positive y, that's going to be quadrant number 2. So now we're going to use this concept to be able to find what quadrant our reference triangle is going to be in, to be able to find whatever ratio it's looking for. So it says, given sine of theta equals 15 over 17 and secant of theta is less than 0, find cosine. So that's what I need to do. I need to figure out what quadrant I need to draw this in, because the triangle is going to go somewhere. So sine relates to y. It says it equals a positive number, so my y is positive. Secant's less than 0. Secant relates to cosine. Cosine relates to x, and it's less than 0, so that means my x is negative. And so now the quadrant that has a negative x and a positive y is going to be quadrant number 2. So let's draw it. So there's my triangle, label the values. My sine is y over r, and so there's my y over r labeled there. Now this is a Pythagorean triple, so if you wanted to use the Pythagorean theorem to find that missing side, that's going to be 8. Now, because it moved in a negative direction, that's why it's going to be negative 8. So now I'd be able to find my cosine. Cosine's x over r, or adjacent over hypotenuse. So adjacent over hypotenuse, I get negative 8 over 17. So the first thing that I did here is I figured out which quadrant the reference angle is going to be in. So I determined my y value is positive, my x is negative, so that's going to be quadrant number 2. And then drawing the triangle in the quadrant, I drew it in there and I labeled it opposite over hypotenuse. And the to find that -8, I had to use the Pythagorean theorem, or in this case it was a Pythagorean triple. But because it moved in a negative direction, that's why it's going to be a -8. And so my cosine adjacent over hypotenuse, and that's how I found it there. So for this one, same thing. First step, figure out which quadrant the reference angle is going to lie in. And so here, my cosine is x, my cosecant is y. Well, my x here is positive, my y is going to be negative because it's less than 0. And so that's going to be quadrant number 4. So now drawing it in that quadrant, now this is my x and this is my r. So adjacent over my hypotenuse r. Now I know my y value has to be negative here, so whatever I find there, it's going down, so that's why it has to be negative. So I'm going to use the Pythagorean theorem to fill in that missing space. So there's x squared plus y squared equals r squared. Now when you go through, you're going to get y is going to be plus or minus 1, which means that y is going to be -1 since it's going to be going down. So now that I know that I have my y value there, then I can find this, find sine. Sine is y over r, and so I have sine of theta equals -1/3. That's our answer. To close today's lesson, what did we learn today? Well, we talked about how to relate our sine, cosine, and tangent functions and relate it to the coordinate plane and how it expressed on the coordinate plane. So to hear back from you, what coordinate does sine relate to, and how can I express tangent in terms of my different coordinates? So this does conclude our lesson. If you have any other questions, please leave them in the comments.